Hi, welcome to webinar series on IoT. My name is Surendra Kumar and I am subject matter expert with Fice Education. Today's webinar is on programming using Arduino APIs and its role in building embedded applications. So before starting off this webinar, let's have a recap of previous webinar which was on getting started with Intel IoT Dev Kit. So in previous webinar, first we discussed about the technology dimension and IoT architecture. Then we talked about the IoT value chain and platforms. Then we discussed IoT value added solutions and services. Then system software support for Intel Galileo Gen 2 board. What type of operating systems are there for Intel Galileo Gen 2 board? Then physical significance of IoT Dev Kit. Then we talked about Intel IoT Dev Kit and what is the importance of Intel IoT Dev Kit. Then we talked about how we can burn the SD card with Intel IoT Dev Kit image. So we discussed building IoT DevKit SD card image also. Then we discussed about accessing the Linux terminal, how we can access the Linux terminal of Intel Galileo Gen 2 board. So in today's webinar, we'll talk about the building embedded applications. Then we'll talk about embedded Linux based system development. Then we will discuss Intel Galileo application development, how we can develop applications using Intel Galileo. Then we will talk about Arduino APIs and programming. Then working with Arduino libraries, how we can add the libraries. Then languages and libraries support for Galileo Gen 2 board. So first question is, what is the embedded system? So basically, if we talk about an embedded system, in technical way, the definition is it is the combination of software and hardware designed for specific application to reduce human interventions. So if I take an example, simply that embedded system is nothing but it is a combination of software and hardware designed for a specific application. So if we talk about the example where the embedded systems are being used. So in day-to-day life, if I take an example of automatic vending machine, whatever controlling part is being done, that controlling circuit is nothing but an embedded system. If I talk about a medical, automobile, then household applications, entertainment, aeroplanes, everywhere, space, everywhere is we are having plenty of embedded systems all around. If we talk about air condition, we have an embedded circuit over there. If we talk about washing machine, we have embedded circuit over there. If we talk about microwave on, we have the embedded system. So all the devices around the world, whether related to entertainment, medical applications, agriculture applications, if we talk about the space applications, everywhere we have the embedded system that are being used in day-to-day life to reduce the human intervention. If similarly we talk about the security alarms, similarly we talk about the drones, everywhere we have the embedded systems. So what is the embedded system application development? So as I already told you, the application definition of embedded system, that it is combination of software and hardware. So what is the basically software? Software is nothing but the bunch of lines written, all right, or we can say the bunch of programs that are written and combined together, it called a software. All right, so how do we write? So we can write program in any of the language. So first we have the source file. The source file can be in C, C++, it can be in Java, it can be some other programming languages. Then we have compiler. So basically the compiler will convert this higher level language into the machine language, and that is called the object files. Then we have assemblers. Then we have the linker. So these objects files given to the linker, then assembler, then library, then kernel. So then this linker will link all these things, objects file, assembler, and take the libraries and the kernel, and it create one executable image file. Now that executable image file is given to the locator. This locator will locate the memory where this image file to be stored. Then we have ROM image file. Then that file is ready to be burned in the image. Then ROM burner will save this file into the ROM, that is read only memory. Then whenever we are starting the system, whenever you are executing the things, then this program or software, or we can say this file, will be going to the RAM. So that is how this system works. Now next is the embedded application development with embedded Linux. How it is working with the Linux. So if we talk about applications or set of tasks are generally written in high level languages like C. So application programming interface APIs consist of functions that applications call and hence request operating system services. So if we talk about the APIs are nothing but the, we can say, consist of functions protocols that are being called, and one complete program is written when we call a API, or it we can say it is a kind of subroutine. Now these subroutines, we have APIs. These APIs being called by the kernel, and then we have embedded processor. So they basically, application program interface consists of functions that applications call. So applications call the functions and then request operating system services. So basically, what is the operating system kernel over here? What is the basically function of kernel? So basically, kernel is called heart of any operating system. So if we talk about the responsibilities and services of kernel, what type of responsibilities and services of kernel? So we can say the role of kernel is to provide interface for applications and hence have the following features. So kernel basically provides the interface for the applications and between the hardware. Now multitasking or multi-threaded capability. So kernel do the task scheduling. Then if we talk about, then next is the support for scheduling policies like round robin, P4, first in first out, last in first out, all these things. Then inter-task communication facilities. Then proper task and resource synchronization mechanism, then interrupt handling mechanism. So these all are the functions of and features of kernel. So all these things are being managed by the kernel only. So that's why the kernel is called the heart of the operating system. Now let's explain it by taking one example of a Linux kernel. So what we do, we have user space, then we have the kernel space. So if we talk about the user space, in user space we have applications or tasks. So for example, these applications or tasks are defined in the higher level languages. For example, if we are writing a application using C, then we have GNU C compiler. That C compiler will convert this into the machine language. Then machine language will go to the system called interface of Linux, and the system call interface will go to the kernel and will request the respective applications. Then after kernel, it will go to the architecture dependent kernel code. So basically, kernel has given various responsibilities like task management, memory management, input output management, and file system management. Now Intel Galileo Gen 2 application development. So basically, what type of applications we can write, what all are the sketches it can support, what all are the programming languages we can use for the Intel Galileo Gen 2 board. So as in previous webinar also, we have discussed all about the libraries and programming languages support for the Intel Galileo Gen 2 board. So we use Arduino IDE to write program using Arduino APIs. Then we can use Intel XDK IoT Edition for JavaScripting. Then we have Eclipse IDE for C and C++. Then we have Velodrine for visual programming. Then we have Linux for the Linux scripting that we can do in the bash. So we can simply say we can write a sketch based on Arduino IDE, XDK IoT Edition, Eclipse IDE, Velodrine and Linux. Alright. So this is what we have basically in Intel Galileo Gen 2 application development. So before starting with the programming with Intel Galileo Gen 2 using Arduino APIs and Arduino IDE, let's talk about the hardware specifications of Intel Galileo Gen 2 board. So basically Intel Galileo Gen 2 based board is based on SoC, system on chip, that is Intel Quark SoC X1000 single core single thread application processor that operates at 400 MHz clock frequency with 12 KB embedded SRAM, that is static RAM. It has ROM of 256 MB DDR3. The storage is 8 MB NOR based flash, 8 KB EEPROM and a micro SD card slot up to 32 GB. So we can insert a SD card or install a SD card of up to 32 GB. So it supports the memory or memory card of up to 32 GB. Then we have connectivity, then 10M Ethernet. So we have Ethernet cable also. Then we have USB, one USB 2.0 host port. Then we have one micro USB 2.0 device port used for programming and debugging. So we have one USB host port and we have USB client port. So these are the hardwares. Then we have 6 pin 3.3 volt USB TTL UART header. Then we have expansion for connecting other peripherals. We have full side mini PCI Express. Then we have Arduino Uno R3 headers that support most Arduino shields. 20 digital input output pins, 6 analog input pins, 6 PWM with 12-bit resolution, and by default the resolution of analog pin is 10-bit, and again it can be extended up to 12-bit. And similarly we have one SPI master, one UART and one shared with the console UART, and we have one I2C master. So basically we can say total 2 UARTs are there and one I2C master. I2C stands for inter integrated circuits. UART stands for universal asynchronous receiver and transmitter. SPI stands for serial peripheral interface, and PWM is nothing but the pulse width modulation. So if we talk about Intel Galileo Gen 2 board specifications, it is the power supply port where you can supply or connect a supply from 7 to 15 volt DC. Then we have input output jumper. Then we already discussed in previous webinar, it can operate on 3.3 volt as well as on 5 volt. So using this jumper you can change this operating voltage that you can have on GPIOs. Then Intel Quark SoC, this one is the Quark. Then 256 MB RAM DDR3 and 128 MB each. Total it makes 256 MB. 8 MB ROM. We have USB host port, USB client port that is used for the programming. Then we have 6 pin FTDI header. Then we have Ethernet port. Then 32 GB SD card slot. Then we have 20 digital input output pins. 14 are the digital pins and 6 are the PWM pins. 6 analog pins. Alright. And out of these 14, 6 are the PWM. So total 14 digital and 6 analog pins. And out of these 14 digital pins, 6 are the PWM pins. And PWM pins are 3, 5, 6, 9, 10 and 11. We can see this sinusoidal sign on the number of the pin. So where on the pin number 3 we have the sinusoidal, 5, 6, similarly 9, 10 and 11. So we have 6 PWM pins. Then we have reboot button. The function of reboot button, if you press the reboot button, it will reboot your processor. And next we have the reset button. So reset will only reset your, we can say the sketch or program. That is the difference. So Arduino APIs and programming. So if we talk about the programming, Intel Galileo Gen 2 can be programmed with Intel Arduino IDE software for using Arduino APIs. Now it's possible to make request of the Linux kernel with system calls. So this gives you your Arduino sketch access to powerful utilities like Python, Node, that is JavaScripting, OpenCV and all sorts of fun Linux stuff. So we can say this Arduino IDE can be used for integrating these multiple programming languages, Python, Node.js, that is JavaScripting, OpenCV and other things. So if we talk about the Arduino library support for Intel Galileo Gen 2 board. So different hardwares requires different drivers. And for accessing that hardwares, we have the libraries. So we have SPI for SPI communication, EEPROM, then UART for UART, then GPIO, then Wi-Fi, servo, USB, and there are many more libraries. Now what is the basic program structure of Arduino? So basically Arduino is having very simple program structure. One is called void setup, another is called void loop. Now what is to be written in void setup and what is to be written in void loop? That is very simple. Whatever we want to execute only once, that is to be written in void setup. So whatever we want to execute again and again, that is to be written in void loop. So that is the basically simple thing. So if you want to define some pin, define the operation of the pin, then that is to be written in the void setup. Second, if you want to monitor, for example, if you want to monitor the temperature, so we want to read the value of temperature sensor again and again continuously, maybe after every 1 minute, every 10 minutes, every hour, like this. So whatever the things that you want to execute, continuously you want to display something on the screen, so that is to be written where in the void loop. So whatever instructions that we want to execute only once, to be written in void setup. Whatever we want to execute again and again continuously, to be written in void loop. Now, digital input output pins. How we can access digital input output pins? So, digital pins basically can act as input pin as well as can be output pin also. So, we can read some digital value and we can write some digital value also. So, basically digital means 0 and 1, low or high, true or false. Only two levels are there, either 0 or 1, low or high. So in case of digital, now it is to define first which pin you want to as a input pin or which pin you want to as a output pin. It means the mode of the pin or direction of the pin we need to define first. Now defining the direction of pin, we have the API that is called pin mode. So basically pin mode API is used to define the direction of the pin. So basically pin mode uses two arguments. One is the pin number, another is the mode. So it is used in void setup to configure a digital pin to behave as a input or output pin. So for example, if we type how we can write, this is to be written in void setup only, pin mode. And remember, this Arduino programming is case sensitive. So M is capital here. So pin mode 13 comma output. So this instruction will make pin number 13 as output. So whenever this instruction will be executed, pin number 13 will behave as a output pin. Means you cannot write, you can now write something on pin number 13. So what we can write, only two values, either 0 or 1. Similarly, if you want to read something from digital pin, then we use the digital read. So if you are interfacing some sensor, all right, with any of the digital pin, so again what should write, first we need to define the pin in input mode. So pin mode 13 comma input, or any other pin also you can take. So now reading the value of that pin, digital read, how many argument it will take? Only one argument, because from where you want to read, which pin? So pin number. So digital read is the API which is used to read the value from digital pin with value either low or high. So it will return with the value either low or high. So this is being used as digital read and the pin number. Similarly, you want to write something on the digital pin. So what we can write, either low or high. Now that is being used as digital write. The API for writing on the digital pin is digital write and the pin number. So it takes only one argument, on which pin, not, it will take two arguments, on which pin and what value. So turns a pin on or off, that is high or low. So digital write 13 comma high. So we want to write high value on pin number 13. So on Intel Galileo Gen 2 board, pin number 13 is connected with the LED. So we have one LED that is, the name of that LED is L. So that LED L is connected with the pin number 13. So we can have very simple experiment to blink this LED L that is connected on pin number 13. Alright. Now this is one example how to access the digital pins. So what we are doing, we are declaring a variable that is integer type or pin number 13. Now we can call pin number 13 as a LED also. It is always easy to give the name. Alright. Now because if you're using the pin number only, that you can if you want to change, make the changes in the program, so what you can do, simply make the changes with the LED. Alright, so you don't have to go for the numbers. Similarly, int pin is equal to 7. So we are giving LED name to pin number 13, we are giving pin name to pin number 7, and we are giving int value is equal to 0. So we are declaring one more variable integer type whose value equals to 0. Now in word setup, what we need to do? we want to turn on the LED L when we press a switch, that is the push pull switch, that is the digital. When you will press it, it will generate a high logic. When you will unpress, low logic. So whenever you press a switch, the LED L should turn on. Alright, so it means we need to connect push pull pull to a pin, and that pin should act as a input pin. Second, we need to write the value on pin number 13, alright, and that should act as a output pin. So in void setup, we will define the mode of both the pins. So pin mode, you can write LED because we have already declared the variable for pin number 13, or if you write the pin number also, then again it will work. So pin mode LED comma output. So this instruction will make your pin number 13 as a output pin. Next is the pin mode pin input. So pin is nothing but pin number 7. So you can write 7 also or pin also. So this one will make pin 7 as a input pin. Alright, so digital pin 7 will act as a input pin now. Now in void loop, what do you want to do? Whenever you presses this, it will read the value. Whatever value is there, then it will write on the pin number 13. So value, we have already declared one variable. Initially the value in the value variable was 0. So now we are reading the pin and storing the value into the value. So value equals to digital read pin. Alright. So pin is nothing but the pin number 7. So it will read whatever is there on the pin number 7. Then next, digital write LED value. So now write that value on the LED. So digital write LED value. So whatever value, whenever you will press in the value, 1 will be there. So you will write the 1 on LED. It means that LED L will turn on. Alright. So whenever it is unpressed, it will keep it off. Alright. So this is one example of how to access digital pin. Next is the analog pins. Alright. So I told you total we have 6 analog pins. Alright. And the instruction or API we say for accessing the analog pin is analog read only, because we cannot generate an analog signal using processors and controllers. Alright. So by default analog pins are the input pins. We cannot write something on the analog pin because we cannot generate an analog signal. Alright. So basically analog pins are nothing but we can say the inputs of the ADC. So this Intel Galileo Gen 2 board have onboard ADC. Alright. So this is nothing but the input of ADC. So obviously we cannot write something and we cannot have the output from the ADC input pins. That is another reason. So analog read is the API. Now what to read, from where to read, obviously we cannot define what to read. It means it will take only one argument, that is the pin number. So usage is to read the value from analog pin from A0 to A5. So by default the resolution of analog pin is 10 bit. How to use? Example, value is equal to analog read A0. So that is the instruction. Now it will map input voltage between 0 to 5 volts. So obviously in an analog pins we can connect the analog sensor, but the output of analog sensor will be analog only. Alright. So if we talk about the sensors, sensors are nothing but the devices that convert physical signal into the electrical signal. For example, temperature sensor, then pressure sensors. Alright. So these are the example of the sensors that convert physical into the electrical signal. While if we talk about the transducers, transducers are the device that convert one type of signal into the another type of the signal. So we can say all sensors are transducers, but all transducers are not sensors. Alright. So it will map input voltage between 0 and 5 volt into the integer values between 0 to 1023. So whatever value your analog sensor will generate, that will be given to the input pins A0 to A5, and output of analog sensor will be the a voltage. Now that voltage level will be converted by ADC into the values from 0 to 1023. So this yields a resolution between readings of 5 volt divided by 1024 units, because total 2 raised to power 10 1024 units will be there, or values will be there. So it will be 0.0049 volts or 4.9 millivolt per unit. So the value read at Galileo's analog port pin is 1000. What voltage in terms of volts in it represents? So we can take an example like you have interface one analog sensor and the value when you are reading the sensor is 1000 because ADC is there, so it will convert that analog value into the digital value, that is 1000 value it will return. Now what is the correspondence voltage, how we can calculate it? So we can calculate it, we know each unit is 4.9 millivolt, so 0.0049 multiplied by 1000 it means 4.88 volt. That is how we can read the analog sensor and convert into the voltage. Similarly, if for example you're interfacing a temperature sensor, so your concern is not the this digital value 1000 or your concern is neither the voltage also, but concern is what the temperature in degree Celsius. So what we can do, first we can read the value, then convert that value into the voltage, then find the sensitivity of the temperature. So if we take an example of LM35, the sensitivity is 10 millivolt per degree Celsius. So whatever voltage signal you will get, for example 4.88 volt we got, simply divided by 10 millivolt per degree Celsius. So you will get the corresponding temperature value. Now analog pins, how we can use. So I told you that by default analog pins are input pins. So no need to use pin mode over here. Alright. So again giving the name to the pins, that int LED equals to 10. So we are giving the name to the pin number 10 as LED. Int pin is equal to 0. Analog pins int value. So declaring one integer type variable called value. In void setup, no need to write anything. In void loop, value is equal to analog read pin. Alright. So A0 pin is given as the pin name pin only. Alright. So you can write A0 also or 0 also, it will take analog pin only. Now we are reading the analog pin A0. So value is equal to analog read pin. So it will read the analog pin and store the value into the value variable. Now you can divide it by 4 because we can, that concept we'll discuss later, why it is divided by 4 and why analog write we are using. Alright. So this is basically function of PWM, pulse width modulation. Alright. So you now just focus on value analog read pin. So it will read the analog pin. Next we'll discuss in next and coming topic. That is the PWM pins now. So other than analog pins, I told you total 20 GPIOs are there. Out of 20 GPIO, 14 are digital pins, 6 are analog pins, and out of these 14 digital, 6 pin can be used for the PWM. Now what is the PWM? PWM stands for pulse width modulation. So basically analog results with digital means using digital control to create a square wave. So what we are doing over here in PWM, we are using the digital pins to control a analog signal. So signal switches between on and off. Simulate voltages between full on 5 volt and off 0 volt. Clear? So we can say we are simply turning on and off. While on is generating a 5 volt, off is 0 volt. So the duration of on time is called the pulse width. So basically we are modulating or controlling the width of the pulse, and width here is the nothing but the on time, and that is called duty cycle. Alright. So duty cycle can be calculated value into 100 divided by 255. So by default the resolution of analog pin is 8 bit. So 8 means 2 raised to power 8, 256. So we can write values between 0 to 255. Alright. So we can generate a 0% duty cycle signal where we have only off state 25%, then 50%, 75% and 100%. So basically average voltage will get the output as the average voltage. So if we talk about a 0% duty cycle and considering a 5 volt signal, then average voltage will be 0. If 25% duty cycle, then average will be 1.25, then 50% obviously 2.5 volt, then 75% Then similarly 100% will be the 5 volt signal. Clear? Now PWM pins. How many pins we have? We have total 6 PWM pins. The standard Arduino API or for PWM output is analog write. Assumes by default an 8-bit resolution capability for the PWM output and so expects a value in the range from 0 to 255. Now Galileo Gen 2 PWM driver supports 12-bit resolution which allows for a more fine grained set of 4096 steps for the duty cycle. So by default the resolution of this is 8-bit. It means 256 steps or range will be 0 to 255. What all are the PWM pins? 3, 5, 6, 9, 10, 11 are the PWM pins. Analog write resolution can be used to set the desired resolution to 12-bit. Alright. So now go back to that same example. We can generate a PWM signal by using analog write. Clear? So what we are doing over here, we are writing the or generating a PWM signal on pin number 10. Alright. So that is given as LED. So what we are doing, analog write LED comma value. Clear? Now what we have to do over here, that one point is being missing here. First you have to declare this pin number 10 as a output pin because this pin number 10 belongs to the digital pin, and in case of digital you have to define as a input or output. So whenever we are generating means output only, we are writing something on pin number 10. It means in void setup you need to write the pin mode here. Pin mode, which pin? Pin number 10, and or you can use the LED also. LED comma output. Alright. So pin mode LED comma output. So this pin number 10 is declared as the output pin. Value divided by 4. So now here is the point. Why we are dividing it by 4? So I told you analog pin is having resolution by default 10 bit. 2 raised to power 10 means 0 to 1023 values you can get from the analog pin. While PWM pin is having resolution of 8 bit means 2 raised to power 8 256. It means 0 to 255. The range that value can be written on PWM. So if you are reading 1023 value, but we can write maximum 255. Alright. So it means that value to be converted into the same range. So by that, for that only, if we divide the analog value read by 4, it will be converted into the same range 0 to 255. Alright. So writing this, that's why we are dividing it by 4. So first we are reading the analog pin, then dividing it by 4, then writing that divided value. Alright. So that is analog write LED comma value. Clear? So that is the example of analog pin and the PWM pin. Now languages and libraries supported for Intel Galileo Gen 2 board. So I told you already that we can use Intel XDK IoT Edition for JavaScripting, then Eclipse IDE for C++, Arduino IDE for Arduino programming using Arduino APIs, Velodrine for visual programming, Cloud Analytics for our Meshery. So working with these all IDs or softwares, we require some libraries. Similarly, we require library for JavaScripting, CCC++, toolchain, Velodrine agent, IoT cloud agent, then libmrra library, then for sensors and actuators library support, all these things. So all these comes under the Yocto based Linux operating system that we discussed in previous webinar. Alright, so we can say libmrra library is used to interface with the input output on your board using these C or C++ library with bindings to JavaScript and Python. Clear? So if you want to work with the Python, JavaScripting, and you want to interface something, and you also want to work with the C or C++ library, that it means you need to add the libmrra. Similarly, REST APIs are used for the cloud analytics, uploading data over the cloud. Then we require Ethernet library, then USB host library, SD library, wire library for I2C, SPI library for SPI. Then all these libraries are there, and some other libraries also there. Similarly, if you want to add some library, but First you need to check whether that library is supported by Intel Galileo Gen 2 board or not. So you can add the library also. I'll show you, and I'll show you one demo of the programming. So for that what you need to do, open Intel Arduino IDE, connect your Intel Galileo Gen 2 board with the computer. So first you need to power up the board. As we have already discussed, the booting of board from the SD card. So I've already installed that booted SD card, burned SD card with Intel IoT Dev Kit on the board. So first you need to connect only the power supply. So when you will connect the power supply, you will observe that only one LED will glow, that is on LED. You need to wait for a while. After some time, one more LED will glow. That LED is called USB LED. Alright. So you need to make sure that USB LED is glowing. Once the USB LED is glowing, now you can connect your micro USB cable to the USB client port. Once after connecting with USB client port, then connect another port of USB cable to your computer, and now open device manager. Open device manager and note down the COM port. So what's wrong this device manager? Alright, now device manager is being opened. Now go to the ports and note down. So here it will show you Intel IoT Dev Kit serial, because I have booted board from the SD card. So if you are not booting your board from SD card, it will show you Galileo here. So if you're booting from SD card, it will show you Intel IoT Dev Kit, and booting from onboard memory or Poki image, then it will show you Galileo only. So note down this COM10. So COM10. Now open your Intel Arduino IDE. Go to tools. Then go to boards. Make sure you have selected the proper Intel Galileo Gen 2 board. Then again go to tools. Then port. Then select the COM port 10. Alright. Now this one is for verifying your code. So I haven't written anything. It is simply structure of the Arduino programming. So you can click this sign where the tick mark sign is given. Clicking this will compile the code and will find if there is any syntax error. It will not find the logical errors. Logical errors you have to find yourself. So it will find only the syntax error. So for compilation and finding the error. So if it written this type of message, it means there is no error. Alright. So let's say I told you we want to blink the LED L that is connected with pin number 13. So what we need to do? First we need to set that 13 in output mode. So pin mode, which pin? 13. In which mode? Output. So write this one over here with semicolon. Alright. Now we want to display this on serial monitor also. So what you can do? You can write serial dot begin, and it takes one argument only, 9600, that is baud rate. It is the rate at which your serial monitor communicate with the Galileo. Serial dot begin 9600. Alright, then go over here, then simply write what we need to do, digital write. So digital, W capital RITE, write. Where you want to write? On pin number 13. What you want to write? High. Now wait for some time. Means we need to add the delay. So delay API is simply delay, and it takes time in milliseconds. So whatever you will write, that is in milliseconds. So I am writing 1000 means 1000 millisecond means 1 second. Then what it will do? Digital write 13 high, turn on the LED. Then wait for 1 second. Then again we need to write low. So now digital write 13 comma low. Now again give the delay. Wait for one more second. DELAY delay 1000. Alright. Now what this program will do? If we starting pin mode 13, first making pin number 13 as the output pin. Serial dot begin 9600 for communication with the serial monitor. Then digital write pin 13 high, delay 1000, digital write 13 low, delay 1000. So digital write 13, it will write the high value on pin number 13 where LED is connected L. Wait for 1 second. Write low means turn off the LED, again wait for 1 second. Now what is the use of serial.begin? These values we can display on the serial monitor over here. Alright, this one. So once your Galileo is connected with the computer, then we can open the serial monitor also. So what we want to display, we want to display something here. So let's say compile the code. Let's see whether there is any error. You can save, you can give any name, my blink, save it. It is saving. Now what is the error? Serial was, so spelling mistake is here. SERIAL. Alright. Now compile. It will take few seconds only in compiling the code. Alright. And again, if there is any syntax error, it will return. So spelling mistake again was a syntax error only. Now you can upload also. Make sure that you have selected this one, board as well as the port. So board we have already selected, port we have already selected. Now this is for uploading the program. Press on it. Again it will take few seconds, and if returns with this message transfer complete means program is successfully uploaded. Now you can make the observation on your board that you can see the pin number 13 or LED L is blinking, which is connected to pin number 13. Now your LED L is blinking. Now we want to display this message over here on the serial monitor. Now we can see nothing is there. We want to display the LEDs on, LEDs off. So what you can do after this, write serial dot print. If you write in double quotes, LED is on, alright, semicolon, and here you want to write serial dot print in double quotes. It will take as a character, LED is off, right? This one. Now again compile the program, upload the program. So it should display whenever LED is on in serial monitor, whenever it is off, off. So LED is on, LED is off, LED is on, LED is off. So now can you see it is printing in one line. We can print in next line also. So simply make the changes in the program. Instead of serial.print, write serial.print ln. Both the sides, serial.print ln. So ln stands for new line. Compile the program, upload the program. You can see LED is blinking, and open serial monitor. Now you can see over here LED is on, LED is off, LED is on, LED is off. So it is displaying in this. Similarly, you can read the value of analog sensor. You can display the value of analog sensor over here. Alright. So all these things you can do. Clear? And you can display the value on the serial monitor also. Now if you want to add some library, what you can do, go to this KH, then import library. You want to add some library, then go to add library. First you need to make sure that you have downloaded the library. So I have downloaded one library, libmrra. So I will show you how to upload that library. Now go to webinar 3, you will see mrra master. So I have already tried uploading, and it was already uploaded. Open it and it will return transfer completed, library named mrra masters already exists. So this is how you can add new libraries or other libraries into this Intel Arduino IDE. Alright, so you can visit these links for further support, and you can write also Foundation for Innovation and Collaborative Education, info@fice.in, mentor@fice.in, and you can visit our website www.fice.in. Thank you.